What's up guys, Major Math with another video on fluid mechanics. If you have any questions, drop it in the comments, and if you're having trouble with other problems, I've attached my email in the description, so please feel free to reach out. Without further ado, let's get started. Okay, question 1.34 in the textbook says a gas will be held in a spherical tank. The gas can be modeled as an ideal gas, so I got a feeling we got to be using the ideal gas law here. The amount of gas is 780 grams, the molar mass is 19 grams per mole, the pressure is 4 atmospheric pressure, gauge, the temperature is 150 degrees Fahrenheit, and it says in millimeters the diameter of the tank is what? Okay, so first step, our goal. Find diameter in millimeters. Okay, and our givens. We have a lot of givens. The mass of the gas is 780 grams. The molar mass is 19 grams per mole. The pressure gauge is 4 atm. We want the absolute pressure. So I didn't know this until I took this class, but there's absolute pressure and then there's gauge pressure. All it is gauge pressure is the pressure of whatever is inside the object, and then the absolute pressure is the gauge pressure plus the atmospheric pressure. So the gauge pressure of inside the spherical tank is 4 atmospheric atm pressure, and then if you want to add the atmospheric pressure, you just add 1 more to get 5 atm, which is equal to the absolute pressure. Yeah, so we want that absolute pressure because that atmospheric pressure is going to be affecting this number, whatsoever inside that tank. So this is the pressure we'll be using. And then it gives us temperature, which is 150 degrees Fahrenheit. Like I said, we're going to be using that ideal gas law, so let's go ahead and convert this to Kelvin while we're at it. It says in the textbook that so I'll show you guys what I'm looking at. So we have Celsius, so we gotta get Celsius, and then once we get Celsius, we can add that 273.15 in Kelvin. So to get Celsius, we do 150 degrees Fahrenheit minus 32 divided by 1.8, which gives us 65.5 repeating, and then you add that 273.15 to get Kelvin, you get 338.7 Kelvin. Okay, so that equals temperature. That's what we'll be using for temperature. Okay, so when you look at this question, it says how we need to find the diameter, right? So we know that we're gonna have to be solving for volume. We're gonna have to be using volume to solve for diameter, right? So let's write down our ideal gas law. Okay. We don't have density. We have pressure. We're given pressure. We don't have density, but we're given the mass. And we're going to want to split this guy up because we know that we're going to have to solve for volume, right? Let's go ahead and split this up because we know, right, that we know that density is equal to this, right? So let's go ahead and change that to this. It says a gas. Let's see. We don't know this yet, but we can solve for it. To solve for the specific gas number or constant, There's a little formula in the textbook right here. It says the specific gas constant equals the universal gas constant divided by molar mass, and we are given the molar mass, and this gas constant's in the textbook. So let's solve for R real quick. So R equals the universal over molar mass, which equals, I gotta see what this constant is. .314 joule per molecule per mole per Kelvin. The molar mass is 19 grams per mole. So these will cancel out. We're left with R equals, well, we'll just leave it as that. We'll plug that in, so I don't have to solve an R. So this is what R is equal to. We'll be using this. And then we know temperature already. We solve for temperature, right? So let's go ahead and rearrange this to be solving for V. So we'll have V equals mRT over P, right? We also know we're going to have to know the volume of a sphere, so I'm going to write it up here. The volume of a sphere is equal to 4/3 pi r cubed. Okay, and then so we'll do that. We'll plug that in because since it's a spherical tank, that's what the volume is going to be equal to. Okay. Let's do some more rearranging, just because we're only looking for that radius. And then once we get that radius, we can multiply it by 2 to get diameter. Okay, so let's rearrange this. If we do some algebra and rearrange it, we get right. Okay, so now we rearrange it and solve for radius here, and everything here we have we can plug in, right? So we know that there is the mass, we know is 780 grams. That's given in the problem right there. We know that this is R values are equal to the universal gas constant over the molar mass, which is 8.314 joules per mole per Kelvin over 19 grams per mole. Okay, and then we know the temperature is 338.7 Kelvin. And that's all over this, and then we know the pressure we solve for is 5 atm. We're going to use pascals just so it cancels out better. So I'll write it up here. One atm is equal to 101,325 pascals. So we're just going to write that here. I think I've said this a lot before in my other videos, but Pascal is equal to Newton per meter squared, and a joule is equal to Newton times meters. So if you convert those, you'll get those to cancel out. If you put this in a calculator, you will get that the radius is equal to 0.379 meters. And that's just the radius, right? We're supposed to find the diameter. So multiply by 2, right? Because diameter is just 2 of that. So that would be 0.758. And the question specifically asked for it to be millimeters. So there's 1,000 millimeters in 1 meter. So we multiply this by 1,000, you will get 758 millimeters. That will be the diameter of the tank. Thanks for watching, soldiers. Don't forget to leave a like and subscribe for more content like this. If you have any questions, leave it on the comments, and if you need help with any other problems, feel free to contact me with the email shown on the screen.